Hi everyone, I'm Shane and I'm a solution architect at Red Hat. And in this video, I want to look at some container security concepts. And firstly, I want to introduce this model for container application development. Now this represents the container application lifecycle. It starts with a new software release, and we package that release into a container image and push it to a registry. And once we have that image in a registry, we can deploy that workload to a cloud-native platform like OpenShift, and then have that pod or container running in production. Now, one of the benefits of containers is that we can start to shift those security practices into development. We can look at integrating security processes throughout this entire container application lifecycle. So for example, we can look at introducing static code analysis and other tools into development, and look at container vulnerability and configuration scanning before workloads make it to production. Now, what I want to look at today is this deployment stage and how we can identify vulnerable code right at the point of deployment and prevent that vulnerability becoming running code. Now, this is important because it allows us to manage risk in a DevSecOps way. We can use the Kubernetes APIs in this case to enforce security policy and provide feedback to developers, operators, and security teams how that workload can be remediated. So let's look at a quick demonstration. I'm going to show a user attempting to deploy a vulnerable application to OpenShift. And in this case, we'll detect at deployment time that there are vulnerabilities in that container image, and we're going to prevent that vulnerability becoming running code. We're going to reject that deployment from the platform. So to enforce that security policy at deployment time, we're going to use this platform, Red Hat Advanced Cluster Security for Kubernetes. And what I have available here is a policy that's going to detect and enforce that vulnerability. So if I have a search here by policy and I search for log4shell, we've got a policy created that's going to alert on log4shell vulnerable deployments. So this policy is able to be enforced across both the build and deploy stages of that container application lifecycle. So we can integrate this in CI/CD pipelines, but we can also enforce this policy at deployment time, and we can identify vulnerable container images and prevent them being accepted and running on that platform. So this is OpenShift and my developer perspective. And this is what it looks like when a user is going to deploy a new application to the platform. So what I'm going to do is specify this container image option. We're going to deploy an existing image from a registry. And in this case, we're going to specify that container image name. So here I've got that container image referenced from our external registry. So I'll give it an application name. And in this case, I'll specify that we're not creating a route into this application. Now, usually when I select create, this workload would be immediately created on my platform. But in this case, we've been able to inject that security policy at deployment time. We've been able to verify that this container image contains a critical vulnerability. In this case, it's vulnerable to a log4j remote code execution vulnerability. And we've prevented that workload running on the platform. But we've also created this guidance for developers, operators, and security teams on how that vulnerability can be remediated. They can apply this guidance. They can go back to that container application lifecycle and build that application again, and then successfully deploy this application and have it running in production without that vulnerability. So what we saw in that demonstration was that deployment time security, that user trying to deploy a vulnerable container application, in this case containing a log4j remote code execution vulnerability, and being able to detect and enforce that security policy at deployment time, identifying that that container image is vulnerable and preventing that workload running on the platform.